Right, we are carrying on the hydrocarbons. Right, synthetic polymers are often manufactured from crude oil. What is crude oil? Crude oil is mixture of a mixture of hydrocarbons, and them hydrocarbons can be really small ones, something like this, where you've got one carbon, 4 hydrogens, that's methane. Remember, each carbon has 4 bonds. It can attach to 4 other things, or it can do a double bond, like ethene, something like this. Look, double bond, carbon, carbon, hydrogen, 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 hydrogen. Remember, we said you need to know this. This is very useful to know. Ethene. Right. Crude oil, you heat it up, it vaporizes, and the top is cool, not hot, it is cool. The bottom is hot. So the ones with the lowest boiling point evaporate first, go to the top, and they are collected at the top. Right. Let's go through this again. Bitumen, fuel oil. I don't think I've done this story. Should I do this story? Yeah, why not? Right. I'm building a road. I'm building a new road. I'm building it to a port where I see a ship waiting, right, to sail away. Right, on the side of the road, I see a truck. A what? Truck. A truck. It's waiting to get on. So what was the first thing? That was a road. We saw a ship. Then we saw a truck. Okay. Then the ship sails off. They look up into the sky, and there is a plane with a kicking cat on it for Kermit the Frog. So this person here is looking out and sees a plane with a K on it for Kermit, and it lands. And because Kermit is super famous, a stretched limousine comes to pick him up. Right, and then it drives off into the Hollywood Hills. And because Kermit is been on a long journey, he's tired and hungry, he turns on the gas cooker to cook something to eat. Probably some bugs or something. Insects. He's a frog after all. Right. So the fourth one was a plane, the fifth one was a car, and the sixth one was gas, cooking gas, camping gas. Right, now what we need to do, what is a road made out of? It's made out of bitumen. What do you use to fuel ships? It's called fuel oil. Now if you come over here, can you see bitumen for the roads, fuel? Then you see a truck driving on. What fuels trucks? Diesel. That's an I, by the way. Diesel. Okay, what's next? And then they look up and they see a plane. It's got a K on it. Kerosene. Kerosene. And then you go to number 5. It's a stretch limousine. It's gasoline. We call it petrol. Petrol. The Americans call it gasoline, so they'll accept either, especially in the UK. Right. Then number 6 is reef. Right. There's two. Excuse me. There's two names that you'll come across. Refinery gases. No. And over here, you've got liquid petroleum gases, LPG. Oh my god, did I just do that? I didn't do that. You didn't see that. Da 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 da. Liquid petroleum gas. There you go. Right. If you can learn that, it'll be superb. This is a good way of remembering it. Right, let's move on. How fractional distillation produces fuel oil from crude oil. So the first thing you do, let's have a look. You heat it. We don't need that. So what you do is you need to heat the crude oil until it vaporizes or becomes a gas. Yeah. Then it rises up the fractionating column. It is okay. The fractionating column is cooler at the top, so fractions as in them, for example, kerosene, gasoline, refinery gases. So fractions with a lower boiling point. So fractions with a low boiling point will condense. Why can't I spell anymore? Will condense and are collected near the top. But fuel oil has a high boiling point, so is collected near the bottom. There you go. Right, okay. Catalytic cracking, 650 degrees, converts fuel oil into propane. Right. So remember we said think of a sandy beach. How do you spell beach now? Okay, we'll stick to beach that way. I think though the beach is a type of tree. Anyway, I digress. Sandy beach. What happens on the sandy beach? You are playing cricket. You're playing cricket. And when somebody balls, look, that is a really light metal ball. Metal ball. What is, when you think of a light metal, you think of aluminium. So just say alumina. Sand, what do you think of sand? Silica. These are your two catalysts. Remember we said that? Now, if you know anything about cricket, when you ball, this person hits it for part of the cricket ground or the stadium or the whatever, and he hits it for 6 runs. So I remember that 6 are 600 degrees Celsius. You can get away with that temperature, but if you notice they've said 650. Yeah. So, and it'll give you anything between that range. But they've asked for the catalyst, so we can put alumina, or silica. The other name that you're gonna come across is alumina is aluminium oxide. Right. It is not it's not aluminum as our Americans friends say. It is aluminium. It is not aluminum. This is haram, not halal. Right, silica is silicon dioxide. Okay, one of the compounds in fuel oil has the formula C17H36. So there's 17 carbons and 36 hydrogens. Now, can you see this here? This is the balancing point. This is the, what can you call it? Reactant. This is the product side. So we've got 17 carbons. We've used how many? We've used 3 there, but we've got 2 lots of them there. So we've really used 2 times 3, which is 6. We've used 6 carbons. We had 17 carbons. So we've got 11 carbons left. Now, how many hydrogens have we got? 6, but we've got 2 lots of them. So we've used 12 hydrogens have been used. And we started off with 36, so we had 36, take away 12 is 24, so it'll be H24. Okay, that's how you balance those out. Right, explain about all compounds. Right, again, what's the definition of a hydrocarbon? A molecule that, I'm splitting it up deliberately, you're going to write it on one line, that contains hydrogen and carbon atom, and then the next line only. So look, learn this definition. Ooh, atoms. There you go. Which 2 compounds in this cracking reaction are described as saturated? Okay, saturated, if I am saturated, I have no more room. I can't handle it anymore. No more room. So that means it's only got single carbon to carbon bonds. Unsaturated has a double carbon to carbon bond. So this bond between the 2 carbons is single. This bond between the 2 carbons is double. So this bond. So what you do, look, if you take the number of carbons and multiply it by 2, so for example, if I had C4, C2H4, if I take the number of carbons and double it and I get the number of hydrogens, that is unsaturated. It's called an alkene. If you take the number of carbons, double it, and then add 2, so for example C2H6, so what I did was I did 2 times 2 equals 4, and then I added 2 and I got 6. Right, I think I've done this before. Remember, CnH2n plus 2. Give another example, C3. So what do? I double it and I add 2, but I don't write it as 6 plus 2, I write it as 8. This is an alkane. It is saturated. It's got no more room. Explain. Let's explain. Okay. So let's write down which they are. C11, H24. Because they are saturated, because they have only single carbon to carbon bonds. Okay, there you go. The relative molecular mass is that. Right, okay, look. What you do, you draw yourself the table again. You put carbone, hydrogene, and sulfure. And then you can put the relative atomic mass is, I know that's 12, I know that's 1. I think that's 32. Right, there's 32, 42, 43, 44, 45, 46, 47. That's cool, yeah. But remember, I've got... How can I do this without messing it up? There's 3 of them. Can you see that there? So this will be 1 times 3. So what's the total empirical formula mass or unit mass? Is 47, but the whole molecule weighs a massive 94, has a mass of 94 units or grams or whatever you want to call it. So I do 94 divided by this number and I get 2. So basically I just double these. Let me do it that. I double these. So what's going to happen is I'm going to end up with C2 H6 S2. There you go. Right, let's keep moving on. Again, crude oil is split up for your camping for gas. So really, do you know, if you can, do not forget the word fuel for camping stove or camping gas. Yeah. Gasoline is fuel. Don't forget fuel. If you forget fuel, you lose the mark. Fuel for cars, aircraft, lorries, ships, and this is for making roads. Describe what is done to crude oil before it enters the fractionating column. You always heat it. Stay out the temperature changes from the top to the bottom. Cool, hot. So it goes, it gets cooler as you go down. I suppose you could, oh, right. I made this mistake. I didn't see this. You heat it until it boils, or vaporizes is better. And then the vapor goes up, it cools down, and then it's collected. Right. How does the temperature change? It is cool at top, increases as you go down. Well, they've said top to bottom, so you could just say it cools, it increases as you go down. Give a use for gasoline, right? We said gasoline is fuel for cars. Remember, we call it petrol in the UK. Bitumen it's for making road surfaces or roads. Right, the one with the largest molecule will be the ones at the bottom, bitumen. State the physical property that allows different fractions. Okay, it's the boiling point. Right, one second. Right, crude oil is a mixture of hydrocarbons. Fractional distillation is a process, and cracking is another process. So fractional distillation separates the crude oil into its fractions, and cracking breaks down large hydrocarbon molecules into small chain hydrocarbons. Which property of hydrocarbons is used to separate? We've just done that. It is going to be the boiling point. That's that one. These are the main fractions: bitumen, diesel, fuel oil, gasoline, kerosene. Give one use for refinery gases. It is for camping gas or cooking gas or bottled gas. Camping gas. Kerosene is right. Listen, do not forget the word fuel, for they always emphasize it in the mark scheme. Fuel for planes or aeroplanes. Most viscous. Viscous is how thick a liquid is. Some students like or laugh at that word viscous. I wonder who it is. Just means thick or runny. So it'll be the one at the bottom, bitumen. Right, let's keep going. Right, what were the catalysts that we used for cracking? Remember, sandy beach and a light metal ball, so you can use silica or alumina. Right, these are the common names, but the chemical name will be silicon dioxide or aluminium oxide. It's best to know both, because if they give you that, then you'll be stuck. Set the temperature. Remember, you knock it for a 6. So when you're playing cricket, and you hit the ball for a 6 outside the stadium, outside the cricket ground, it will be 600 degrees Celsius. Tetradecane can be cracked to make ethene and one of the hydrocarbon. Right, okay. What this side trying to say to you, you start with C14H30 and you crack it into C2H4. They've given you that, plus something else. Right, so we had 14, we've used 2, so we're going to have 12 left. 14, take away 2 is 12. Then what you do is you had 30 hydrogens, you got rid of 4, so you've got 26. There you go. Draw displayed formula for ethene. So ethene is always double bond, Do not forget to include the hydrogens. Name the polymer formed from ethene. It's polyethene or polythene. Yeah, just polyeth. Polyethene is probably better. Right. Explain why this polymer is difficult to dispose of. Because it is inert. So to marker, it is inert. Inert means unreactive. You cannot. It does not biodegrade. What does that mean? It microorganisms can't break it down. It is inert. It is inert, so does not biodegrade. Just learn this. They ever ask you, just learn that. Right, name the distillation process used to separate crude oil. It is called fractional distillation. Fractional distillation. Right. State kerosene, bitumen. Kerosene, remember, use the word fuel for planes. Oh my god, I can't spell planes anymore. It is a disaster. Fuel for aeroplanes and bitumen is for making roads. Just leave it like that. Let us move on. I can't say that. Ecosane. 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 Sounds like a medicine. Right, has the formula C20H42. 20 carbons, 42 hydrogens. Explain which homologous series. Is it alkane? Is it alkene? What you do is, let me test it. For an alkene, I take the number of carbon atoms and double it. And it should give 40 if it's an alkene. If it's not an alkene, I need to add 2. So if I double the hydrogen, carbon, it becomes 40. And if I add 2, it becomes 42. So it becomes C20H42. Right, now, so it's obviously this one. So it's an alkane. Because what's the general formula? CnH2n plus 2. It is alkane because it has general formula CnH2n plus 2. Right, remember what we said? You take the number of carbons, double them, so 20 becomes 40, and then you add 2 and it becomes 42. That is what makes it an alkane. Name the catalyst used. Remember there's 2 catalysts: sandy beach, silica, light metal ball, alumina. It's not aluminium, it's alumina. How else did we remember it? Silicon dioxide, aluminium oxide. Okay, let's move on. Balancing. it is as the balancing. We have 20 carbons here. We've got 4 here, but we've got 3 lots of 4. So that there is 12. So we've used 12 carbons. We had 20. So we've got 8 left. So we see 8. Now the same thing with this. There's 8 hydrogens, but there's 3 lots. So 8, 16, 24. We've used 24. We had 42. It becomes 18 left. H18. Okay. What is a hydrocarbon? Again, you have to learn this. It is a molecule that contains hydrogen and carbon atom. So it contains hydrogen and carbon atoms only. So remember what we said, there's 3 parts to it. Just remember molecule, hydrogen, carbon atoms, and only. State what is meant by a hydrocarbon being saturated. If something is saturated, it is a molecule that has a double carbon to carbon bond. There you go. Right, describe a chemical test between unsaturated and saturated. Simple. You add orange, bromine, water, and it turns. If it okay, I don't like using the word if the hydrocarbon if the hydrocarbon is unsaturated, it will become colorless. The solution becomes colorless. Oh my god. Colorless. Don't say clear. They don't like clear. Right. What's an isomer? Can you remember what an isomer is? It is a molecule with the same molecular structure but different displayed formula. Or instead of using the word displayed, you could have used structural formula. Structural formula. Right. Methane, ethane, propane, butane. Name this isomer. So look, meat, eat, prop, bute. Look, monkeys eat peanut butter. Meat, eat, prop, and bute. So it's going to be bute. And then because it's got a double bond, it's going to be, instead of ane, it's going to be butene. You could have said bute 1-ene. That's 1, by the way. Bute 1-ene. Why is it 1? Because it's on the first. The double bond. Get rid of that. The double bond here is on the first carbon. We'll discuss that if we need to some other time. Right, draw displayed. Right, all I'm going to do is I'm going to move this double bond let me show you here. I'm going to move, get rid of U. No, I can't get rid of U. Right. I'm going to move this double bond from here to here. That's all I'm doing. So all I'm going to do is, look, I'm going to draw 1, 2, 3, 4 carbons. The double bond was here. I'm going to remove it from there and I'm going to move it to here. So I've got 1 carbon, 2, 3, 4. 1, 2, 3, 4. So this will be butene. There you go, done. Right, you could have had, I mean, you could have done it this way as well. They've got this on the mark scheme, so you've got carbon, you've got 1 hydrogen there, 1 hydrogen there, right, and you've got right, and then from there they've put the carbon with 3 hydrogens up there. I think that's a methyl group, so it's still an isomer of that. Right, oh, that's it. Right, that was a tough one, but you can see the repetitiveness of these questions. So if you can get through this topic paper, you'll tackle any of the questions that come up with any exam, inshallah. So okay, let's move on.